Are you ready? Okay.
We can have a couple lines for you on him by the time
Just a
we get.
bio. Yeah, by the time I
By the
finish
time
this.
we.
Yeah. Okay. I don't have a bio yet, but I'm going to introduce him after we get going. Before I ask my questions, maybe.
Oh,
We
okay.
forgot to prepare anything, so we're preparing something
Oh, okay.
now. The Committee on Science, Space, and Technology will come to order. With that objection, the chair is authorized to declare recesses of the committee at any time. And welcome to today's hearing entitled Energy Innovation, Letting Technology Lead. I'll recognize myself for an opening statement and then the ranking member for her opening statement. Today we will hear from a panel of private sector innovators who are inventing the way to bring next-generation technology to the energy market. New technology provides solutions to today's energy and environmental challenges. Instead of government mandates, more regulations, and higher energy taxes, the federal government should invest in the research that allows innovative technology like advanced nuclear power and energy storage to succeed. We should all agree on these technology-driven energy solutions. Unfortunately, nuclear power, which is the only reliable emissions-free source of electricity, is still criticized by environmental activists today. Those who are sincerely interested in solving some of America's environmental challenges should endorse and promote these critical new technologies. This hearing will consider the value of federally funded basic and early-stage research, as well as the research infrastructure at universities and national labs. These investments provide valuable expertise that would otherwise be unavailable to industry. The Science Committee has jurisdiction over the $9 billion R&D portfolio at the Department of Energy, which funds basic science and energy research. Fundamental research conducted by the DOE Office of Science has led to groundbreaking discoveries about our universe, innovative new technologies, and private sector achievements across the energy and manufacturing industries. Much of the technology we will hear about today is rooted in the basic science discoveries made at DOE national labs. Industry can build on these early-stage research discoveries and use research infrastructure to create market-ready, next-generation energy technologies. For example, Dr. Jacob DeWitt, who started his career as an intern at Sandia National Lab, is the co-founder of Oklo, a privately funded startup company working to commercialize a small, advanced nuclear reactor design. Dr. DeWitt's compact, fast reactor design is ideal to replace the diesel generators used in rural areas, industrial operations, or even on military bases. This reactor was developed using early-stage nuclear energy research conducted by DOE national labs. It will have zero emissions and could lower costs for consumers by up to 90%. If environmentalists are serious about reducing emissions, they should champion advanced nuclear reactors as an essential part of a clean energy future. At UCLA, Dr. Gurant Sant and his team have used basic research in chemistry, material science, engineering, and high-performance computing to design a technology that converts carbon dioxide into cement-like material. This technology could take captured carbon dioxide from power plants and turn it into a usable, cost-effective material. This innovative technology has the potential to revolutionize the market for CO2, turning a waste product into profit. Even large companies can benefit from basic research. AES Energy Storage is revolutionizing renewable energy through the deployment of batteries for the electric grid. AES's most recent project in California is capable of storing up to 120 megawatt hours of energy produced by wind and solar power. This is the energy equivalent of serving 20,000 customers for 4 hours. Basic and early-stage research in electrochemistry can improve the efficiency and resiliency of the thousands of batteries used in these facilities. This committee authorized exactly this kind of basic and fundamental research in the DOE Research and Innovation Act, which passed the House earlier this year. Enabling these private sector innovators to develop the most competitive ideas is essential to groundbreaking energy technology. If we want to protect the environment, lower costs for consumers, and increase our energy potential, innovative technology is the solution. And note that during the White House Made in America Week, we have 3 American companies testifying on innovative technology. By allowing the market, not the government, to determine the best approach, we can develop technology that will increase energy efficiency, reduce environmental impact, and save the American people money. America's energy history is full of innovative technologies that have unlocked new possibilities. It is technology, not regulation, that improves efficiency, lowers cost, and reduces the environmental impact of all kinds of energy. For too long, the government has picked winners and losers through regulation, federal loans and loan guarantees, or market-distorting subsidies. It is time to let the scientists, researchers, engineers, and inventors ensure that the United States remains the world technology leader and is better able to address environmental concerns. As we shape the future of the department, our priority must be basic energy research and development that only the federal government has the resources to pursue. This will allow private sector innovators, like the witnesses who join us today, to take groundbreaking energy technology to the marketplace, creating jobs and growing our economy. That concludes my opening statement, and the gentlewoman from Texas, the ranking member, is recognized for hers.
Thank you very much, Mr. Chairman, and thank you for holding this hearing. I'd like to thank all of our witnesses for being here today. In years past, this committee would hold an annual hearing on the administration's budget proposals for the Department of Energy, and I would typically begin my remarks with a few brief reminders of how government-supported energy research can pay off, ranging from the birth of the nuclear power industry to the shale gas revolution. I then move on to provide my views on what usually was a thoughtful, well-crafted budget proposal, even if I might have had some disagreements with it. Unfortunately, this is not a typical year. First, while the administration's budget blueprint was released back in March and its detailed budget request was released in May, our committee has still not yet scheduled a hearing with Secretary Perry, testifying to explain and defend his proposal. While the panel before us today has a broad and impressive range of expertise that will at least enable us to begin this discussion, none of these witnesses can speak for the department. In order for this committee to fulfill its oversight responsibilities, I urge the chairman to schedule a hearing with the secretary as soon as possible. As for the fiscal year DOE budget request, I want to be clear. I am deeply disturbed by the Trump administration's proposed budget for the Department of Energy. It would completely eliminate ARPA-E, an agency that has already demonstrated incredible success in advancing high-risk, high-reward energy technology solutions that neither are the public nor the private sector have been willing or able to support in the past. This accomplishment was highlighted in a congressionally mandated National Academies review of the agency released just last month. Bipartisan industry leaders like Norm Augustine and Bill Gates have repeatedly called for tripling this agency's budget, given the unique role that it is now playing in an energy innovation pipeline. And I'd be remiss if I didn't refer my colleagues to Secretary Perry's March 8th tweet, issued just 8 days before the budget blueprint was released, which states, and I quote, "Innovators like the one supported by ARPA-E program are key to advancing America's energy economy." I really couldn't have said it any better. In addition, the President's budget proposal would eliminate DOE's loan guarantee and advanced vehicle technology manufacturing programs. Mr. Chairman, we just held a hearing on these programs a few months ago, and we learned that their record of accomplishment more than justifies their continued support. The DOE Loan Programs Office have been instrumental in launching the utility-scale PV industry. Tesla Motors, the construction of our first new nuclear reactors in 30 years, and it is now supporting the commercialization of new carbon capture and reuse technologies. Overall, the loan office's losses are only 2% of its entire portfolio, a rate that is lower than many venture capitalists achieve. And even after accounting for those losses, the interest payments from these loans and loan guarantees have returned over $1 billion to the Treasury. If we're aiming to create jobs and reduce the deficit, these are exactly the programs we should be supporting. Finally, the budget proposal would slash the department's other critical energy technology offices for energy efficiency, renewables, the grid, fossil energy, and nuclear energy by $2.3 billion overall, or about 57%. And it would cut the DOE Office of Science, the largest supporter of physical scientist research in the country, by over $900 million, or 17%. Our national infrastructure for scientific and energy research would be irreparably harmed if these cuts were actually implemented. Now, I'm not going to tell you that every program the department currently implements is perfect, but that reforms should never be considered, or that reasonable people can't simply disagree on the best way to allocate its resources, even after a careful, rigorous review. One of my largest concerns now, especially given the incredibly severe damage that this proposal would impose on our entire research enterprise, is that such a thoughtful review never actually took place before this budget proposal was released. In fact, last month, administration officials confirmed that there was no engagement with the private sector at all to determine what industry would be able or willing to fund in the absence of federal investment. This is simply unacceptable. In closing, I hope that we can all take a step back and more carefully consider the direction we want to move the department in over the next several years. I look forward to the hearing and listening to our witnesses on all of these critical issues. I yield back whatever balance of time I have.
Well, actually, there's not much balance left, but I appreciate the gentleman yielding back. And thank you for your statement. Before I introduce our witnesses today, I'd like to introduce the newest member of the Science Committee, Ralph Norman of South Carolina. Having served as a former state rep in South Carolina, he brings a wealth of experience to the committee, and he's going to be serving on the Environment and Oversight subcommittees. And Ralph, we welcome you to the committee. And I'll go to our witnesses. Our first witness today is Dr. Jacob DeWitt, co-founder and CEO of Oklo. Previously, Dr. DeWitt worked at Sandia National Lab, Urenco US, and the Naval Reactor Research Laboratories. He studied nuclear engineering at the University of Florida and received his PhD in nuclear engineering from MIT. Our next witness is Dr. Gaurav Sant, Associate Professor and Henry Sumilai Fellow in the Department of Civil and Environmental Engineering at the University of California, Los Angeles. Dr. Sant received his bachelor's degree, master's degree, and PhD from Purdue University. Our third witness today is Dr. Vinke, and he prefers to be called by his first name, Dr. Vinke, which makes it easier on all of us. Dr. Vinke is the Benjamin Pierce Research Professor of Technology and Public Policy at Harvard's John A. Paulson School of Engineering and Applied Sciences. Dr. Vinke previously served as Dean of the John Paulson School of Engineering and Applied Sciences and Dean of Physical Sciences at Harvard. He received his bachelor's and master's degree in physics from St. Stephen's College, Delhi University. Our final witness today is Dr. Karan Kumaraswamy, Market Development Director at AES Energy Storage. He previously served as the Senior Manager at ICF International in Fairfax, Virginia. He received his bachelor's degree in electrical engineering from the University of Madras,
yeah.
Madras, and his master's degree in engineering from the University of Wisconsin-Madison. We welcome you all to the committee hearing today. Look forward to your testimony, and Dr. DeWitt will begin with you.
Thank you. And Chairman Smith and Ranking Member Johnson and distinguished members of this committee, I want to thank you for holding this hearing and for giving me the opportunity to testify today. I am honored to be here, and I'm eager to share my experiences commercializing advanced reactor technologies that build upon a rich legacy of research and development within the National Laboratory System and the Department of Energy. As Chairman Smith mentioned in his intro, I was fortunate to grow up around Sandia National Laboratory, which played a huge role in influencing my decision to go into the fields of technology, science, engineering, and math, as well as pursue ultimately an entrepreneurial career. And I'm also excited to be working with them now further to commercialize this technology. So I am the CEO and co-founder of Oklo, a Silicon Valley-based company developing and building a very small advanced reactor that produces 1 to 2 megawatts of electric power. We sometimes refer to this as a microreactor that is designed to bring distributed, clean, affordable, and reliable nuclear power in small packages to a wide variety of markets, both domestically and internationally. We started Oklo because we believe advanced reactors will play a significant role in the energy mix of the future, and we want to make that future a reality as quickly as possible. Over half of the active advanced reactor commercialization efforts ongoing in the United States today are pursuing fast reactor technologies. One of the key technologies to the success of fast reactor R&D in the United States has been the development of metal fuels. Metal fuels are alloys of uranium or other actinides that combine incredible durability, flexibility, and resilience to achieve phenomenal fuel utilization, manufacturability, and safety performance. Metal fuel was used in several key early experimental reactors operated in the 1950s and 60s and showed great promise, but it was sidelined until several key engineering discoveries were made through R&D campaigns sponsored by the Atomic Energy Commission and then the DOE, which ultimately enabled the fuels to realize their potential. These advances were highlighted by successful demonstrations at the EBR-2 reactor, which operated in Idaho. Over half of fast reactor developers in the U.S. are building upon this rich R&D legacy in metal fuel, and it is a striking example of a successful government investment in R&D that matured a promising technology to the point and readiness of commercialization. There are also opportunities to expand on the successes in metal fuel. Lessons learned identified new avenues to enhance its capabilities, which illustrates the continuum of innovation that can occur when one discovery leads to many more that can further advance the state of the art. At Oklo, we are working to commercialize a reactor that builds on the successful legacy of metal fuel. We pursue a business model of following market needs and demands. In other words, we strive to make reactors people want. It can be tempting to push an exciting new technology to market, but then miss what the market needs for the sake of the technology. So talking to users to understand what the market requires and wants takes discipline. In our experience, we have found the capabilities offered by metal fuel match customer needs and have continued to find market fit and traction, thanks in part to R&D success of metal fuel. We've partnered with several national labs to date, including Argonne, Idaho, and Sandia National Laboratories, to support our commercialization work. A significant amount of this work has focused on commercializing our specific application and design of metal fuel. For example, we are working with Argonne and Idaho, supported by the Gateway for Accelerated Innovation in Nuclear, also known as GAIN, to assemble fuel performance data that we've used in formal pre-application meetings with the NRC to support our licensing case, as well as to fabricate 3 prototypic fuel elements demonstrating key characteristics, which we were excited to announce all 3 hit production specs. We are currently expanding our work with the national labs because many of the capabilities we need are uniquely found in the national lab complex, providing us with an international advantage. This is why it is so important to maintain and preserve our capabilities and expertise in the national lab system, and also why we need to develop new capabilities, like a fast test reactor. In fact, I would like to highlight the efforts to build a fast reactor that this committee and Congressman Weber has so earnestly led and supported in a bipartisan way. This is incredibly important to develop this capability in the United States because the construction and operation of a domestic fast test reactor will pay substantial dividends to American energy competitiveness as well as leadership. This facility will be a national asset and will not only accelerate ongoing advanced reactor commercialization efforts, but will also be the catalyst for new innovations and new technologies. Furthermore, to support ongoing innovation, DOE needs to provide a fuel source for demonstration, prototype, and first-of-a-kind advanced reactors by providing low-enriched uranium enriched above the 5% enrichment that current LWR fuels use. In general, the regulatory challenges that we face in advanced reactor space have been overstated. And I'd like to take a few minutes, or a few moments, I should say, to comment on that. While there are challenges, I must emphasize that the widely held view that advanced reactors cannot be licensed today is mistaken. We are formally engaged in pre-applications activities with the NRC and have found clear licensing pathways for our technology, but work remains. Innovation in nuclear is proceeding at a pace reminiscent of the early days of nuclear power, and the U.S. is still the global leader. But we need to be mindful of international competition. China and Russia are investing heavily to develop advanced nuclear technologies, and we cannot afford to fall behind. Our national capacity to innovate, combined with our national capabilities to research and develop, give us a tremendous advantage. Thank you.
Thank you, Dr. DeWitt and Dr. Sant.
Thank you, Chairman Smith, Ranking Member Johnson, and members of the committee for inviting me to appear before you as you review private sector leadership in next-generation energy technology to increase efficiency, environmental benefits, and consumer savings, and review associated research and regulatory hurdles. As is requested by the committee, I'm focusing my testimony on research that we've been engaged in that seeks to convert carbon dioxide, CO2, into a novel building material, concrete, with a CO2 at the front. The views expressed herein are my own and do not necessarily represent those of UCLA. In brief, I'm an associate professor and Henry Samueli Fellow in the Henry Samueli School of Engineering and Applied Science at the University of California, Los Angeles. I'm a civil engineer and a material scientist with broad-ranging expertise in material synthesis, characterization, and simulation. My testimony today can be summarized as follows, starting with the motivation. Electricity generation from coal-fired power plants alone represents about 25% of CO2 emissions from the United States. It's about 1.2 billion tons of CO2 was emitted in 2016. Carbon capture and storage has been proposed as a solution to mitigate CO2 emissions caused by industrial activities. However, CCS is not always viable due to issues associated with high cost, uncertainty in the permanence of the sequestration solution, and/or the lack of suitable geological features in the local vicinity where CCS can be achieved. Therefore, it is necessary to identify and create new pathways for the beneficial utilization of CO2 while simultaneously yielding a permanent CCS solution. A novel approach to mitigate CO2 emissions is by upcycling or beneficially utilizing industrial waste that might be in the form of solids, liquids, or vapors to create new materials, for example, concrete. As an example, in the case of flue gas-borne CO2, this is accomplished by converting gas-borne CO2 by mineralization into stable carbonate compounds, which might offer cementitious character into building materials. Not only do such innovative technologies yield environmental benefits, but they also have the potential to reduce the environmental impact of the construction sector as follows. The production of ordinary Portland cement, the primary binding agent used in traditional concrete, results in nearly 9% of global CO2 emissions. For example, nearly 0.9 tons of carbon dioxide are emitted per ton of OPC produced. Therefore, the development of new cementation agents that take up CO2 will help reduce emissions associated with OPC and concrete production. In the perspective of material recycling, the simultaneous reuse of CO2 in industrial byproducts, solid waste resulting from coal combustion, creates a new paradigm in waste-to-resource recycling of materials. This creates a circular economy paradigm between the energy and construction sectors and thus greatly enhances the sustainability metrics of both industries. The upcycling process that we've proposed and demonstrated is accomplished by contacting calcium hydroxide with flue gas-borne CO2. Such calcium hydroxide or portlandite can be secured by calcining limestone and hydrating the lime that results, or by leaching calcium species from alkaline industrial waste such as slags and coal combustion residuals. Following combination with fine and coarse mineral aggregates, chemical additives, water, and suitable binding agents if needed, similar to traditional concrete, this mixture containing calcium hydroxide forms a slurry that can be shaped into common construction elements such as beams, columns, and slabs. Importantly, the upcycled concrete process is designed to bolt on to large point source CO2 emitters, including petrochemical facilities, coal and natural gas-fired power plants, and cement plants. In each case, emitted flue gas is used to provide both waste heat to hasten chemical reactions and to provide CO2 to ensure mineralization without imposing any additional need for emissions control. The process cycle is being designed for scalable operations to accelerate the R&D pathway towards pilot-scale trials, technology commercialization, and deployment. Concrete offers a transformative route for the beneficial utilization of flue gas-borne CO2 in the cementation cycle. This creates pathways to produce construction materials with up to 50% or lower carbon dioxide intensity than ordinary Portland cement. Furthermore, by creating a robust CO2 and solid waste offtake partnership between the energy and the construction sectors, the outcomes of this work create new sectoral synergies which would be difficult to realize otherwise. Significantly, the CO2 upcycling approach can reduce the environmental impact of electricity generation from fossil fuels while simultaneously advancing the materials, methods, and processes used by the construction sector. Financial support secured from federal agencies, including the Department of Energy, the Department of Transportation, and the National Science Foundation, have been instrumental in enabling our work. The support of federal agencies such as those noted above and others is critical for enabling basic and applied R&D, technology creation, and development. Broadly, with significant competitive international investments in R&D around the world, federal support of basic and applied R&D in core and emerging domains such as CO2 utilization and reuse is more important now than ever. This is because federal R&D support is vital to enable the creation of knowledge and technology within universities and national laboratories, the reservoirs of knowledge that have ensured U.S. intellectual leadership globally. Furthermore, federal support of R&D is especially important in the case of technologies which benefit conventional industries which are unlikely to be offshored, for example, electricity generation in the construction sector, but which feature reduced appetite for technical and commercial risk due to uncertainty in revenue, profit pressures, regulatory and compliance burdens, or high costs associated with the development of greenfield facilities with long operating horizons. Therefore, it becomes necessary for the government to underwrite a larger proportion of the costs associated with R&D that has the potential to benefit such industries, and in general, the general public, until sufficient technology maturity is achieved. However, once such maturity is achieved and industry is assured of the commercial value and potential of new technology, it is expected that industry will take over and accelerate the residual R&D pathway, including commercial trials that results in market penetration and diffusion of new technology. Thank you again for the opportunity to testify on this important topic.
Thank you, Dr. San and Dr. Venti.
Thank you, Chairman Smith, Honorable Minority Leader Johnson, and members of the House Space, Science, and Technology Committee. I thank you for this opportunity to speak about the role of public
Is your mic on? There we go. There.
Can you hear me now?
Yep,
Yeah.
thank you.
Thank you for the opportunity to speak about the role of public policy in energy innovation. My perspective comes from a lifetime of working in science and technology, first at AT&T Bell Laboratories, then in national labs, Sandia National Lab, and in academia, as well as my recent research at the Harvard Kennedy School and my role on several committees of the National Academies and the American Academy of Arts and Sciences. I have three main points to make to you today. First, we must break down the false dichotomy between so-called basic and applied research. In my lexicon, there's only one word, research. And research must be scientific research, physics research, technology research, engineering research. Second, in energy alone, history has shown that sometimes engineering inventions precede detailed scientific understanding, and sometimes new scientific discoveries lead to new engineering inventions. The creation of the steam engine 200 years ago by James Watt led to the Industrial Revolution long before the science of thermodynamics. Science of thermodynamics to make better steam engines. The invention of the light bulb by Edison and transformers led to the field of electrical power engineering. On the other side, the scientific work of Einstein, which showed the connection between mass and energy, and the work of Enrico Fermi on nuclear fission led eventually to nuclear power. My second point is that government has an important role in fostering energy innovation done in the proper way, which couples the desire to understand and the desire to create new things. That's what America is about, in my view. If we do not combine so-called basic and applied research, it's a missed opportunity. We learn by doing. Everything I do, even in class, we learn by doing. The private sector in energy in particular does not invest appropriately in long-term R&D. In fact, that's true widely of the American economy because of the global competition and because the fruits of this research cannot be easily captured because of the risks and the breadth of those values. This leads to valleys of death, which government funding is needed to overcome. The early stage one, which is where I'm expert of, transformative, it really is important because, in fact, the risks are huge, but the gains also can be very large. High risk, high reward, as Honorable Johnson mentioned. Technology transfer, secondly, is a body contact sport. It requires interactions, collaborations with actors from places like the national labs, universities, and the private sector. I now want to turn to a few points on the role of the U.S. Department of Energy, which has its mission, general science, as well as energy and national security. In the energy space, Department of Energy investments in the past have led to major technological advances, such as the shale gas revolution was mentioned, which we are losing the fruits of today. It was done in the 1980s when people at the DOE and the Gas Research Institute helped an entrepreneur by the name of Mitchell Energy. The big companies didn't want to do it, and it was not, of course, cost-effective then, but today it has become a huge effect here. There's similarly nuclear power, which has also been mentioned, and solar photovoltaics. So this has often been done by the so-called applied officers in the DOE. The full potential the Department of Energy's worth in this space can only be realized by further breaking down the boundaries between basic and applied research. Recent attempts to break down this boundary and the creation of interdisciplinary research efforts through Energy Frontier Research Centers, Energy Innovation Hubs, and ARPA-E were, in my view, the steps in the right direction, including the creation of a unified Undersecretary for Science and Energy. We do want to break down these barriers, and if I may be, as a respectful reminder, point to this committee, which also has responsibility for the National Science Foundation. Eric Bloch, who came from IBM and understood the industrial lab culture, in the 1980s changed many of the NSF features in a very positive direction. He created physics frontier centers, he created science and technology centers, and he created engineering research centers, which have a 40-year history of great success and have been evaluated in books. The recent constructs at DOE, in fact, emulate them. Energy innovation hubs are like science and technology centers and like engineering research centers, and they deserve to be funded just as the Physics Frontier Center. So this is not against the basic research, it is how you keep the boundary. So NSF 40 is really, so I would like to say this, the great diversity and complexity in energy science and technology calls for a portfolio approach, both in terms of content and management. I did not mention ARPA-E. ARPA-E is a slightly different construct, which where actually the program managers modeled like DARPA to actually go for the high-risk reward, and we have done studies on it, which I can speak about later in questioning, which actually shows the enormous benefit which ARPA-E has also done. So in closing, I believe we are in a critical juncture, and our choices today will have far-reaching consequences. I cannot overemphasize the importance of government support of energy innovation across the basic applied divide, and enhancing collaboration and cooperation between academia, national laboratories, and industry. Thank you.
Thank you, Dr. Benke. You certainly know how to message research. We'll now go to Mr. Kumaraswamy. Look forward to your comments.
Thank you, Chairman Smith and distinguished members of the committee. I'm honored to testify in front of you today on the topic of energy innovation and private sector leadership in commercializing new technologies. Innovation can and will transform the energy sector and in turn people's lives. Bringing change to the industry is part of our DNA at AES, and in turn, many ways is what we do best. AES was started 35 years ago by two former government employees, Roger Sant and Dennis Paki, who saw an opportunity in the emerging independent generation market and continue to grow by innovating new solutions to serve emerging power sector needs. We think innovation is very different from invention. Invention is a new idea. Innovation is actually doing something with the idea or applying an existing idea in a new way to drive a greater impact. That means that to AES, innovation can happen not just through technology, but by thinking about business models differently or modifying market structures. It's an approach we call applied innovation. There's no better example of our applied innovation approach than in our energy storage business. We've come far from where we started 10 years ago in the energy storage business. Back then, battery-based energy storage on the grid was experimental and did not exist as a business opportunity. Today, it is a proven solution and is operating successfully across the country and in several global markets. We stand at the beginning of the next big scaling up, taking this vital technology to more customers, more countries, and more grids around the world. In the context of today's discussion on applied innovation, it's pretty important to understand how we got here. In 2007, AES Energy Storage was founded as a subsidiary of AES to carry forward our initial survey of advances in battery technology and power electronics. At the time, no one had designed a large-scale energy storage system using lithium-ion batteries. The conventional wisdom of the time was that batteries could not meet the challenges of utility-scale performance. As lithium-ion technology emerged, our team believed we had found useful business cases for battery-based energy storage systems. We moved forward with designing and building the first megawatt-scale lithium-ion battery storage project. Several years later, with 20 projects now and 398 megawatts deployed and awarded across 7 different countries globally, we have helped ensure more customers in more locations can benefit from energy storage. In 2014, in California, we demonstrated that batteries could compete successfully against peaking power plants, securing the world's first power purchase agreements for energy storage to serve a utility customer for 20 years, and still the largest contracted energy storage project in the world. Just last week, Siemens and AES announced we will join forces to create Fluence, a new global energy storage technology and services company that unites the scale, experience, and reach of its two parent companies. With the market at an inflection point, what did we as a private sector company learn about commercializing next generation technologies in the power market? I'd like to make 4 points to the committee. First, the existing power market is not designed to reward innovators, and many of the needs reside within the network without any capability for compensation. Many of the rules in the current power markets were put in place for traditional generation and do not fully account for technical and performance characteristics of advanced technologies like energy storage. It is important to remedy these regulatory concerns as soon as possible. The federal government has an important role to play here to ensure markets are fully competitive and have the policy in place to catch up with technology. Otherwise, market rules set up several years ago become an unintended roadblock to commercializing energy storage. The Federal Energy Regulatory Commission currently has a notice of proposed rulemaking related to removing barriers for storage participation in wholesale power markets. These types of efforts that include reforming market regulations to enable storage to compete in markets should be accelerated. Second, on the topic of battery chemistry research, we believe that lithium-ion is mature right now, and private capital from large battery manufacturing companies is moving it forward at an incredible speed. The government should continue funding R&D on other early-stage battery chemistries that have the potential to achieve greater capabilities in the near future. Third, the national labs through the Department of Energy are doing a great job in advancing the modeling and visualization of benefits that energy storage brings to the grid. These are complex analytic simulations that require the use of state-of-art power market models and a high degree of computational rigor. The government should continue to encourage and increase investments in the DOE and national labs to continue this important work. Finally, the last point that I would like to make is that the federal government should continue to provide technical assistance to storage project deployments, particularly for states and utilities that are considering their first projects, but may be constrained by lack of technical experience. Through our experience in the energy storage business, we have found that deploying projects in the field is the best way to enhance learning among all stakeholders. Mr. Chairman, thank you again for the opportunity to testify today. I would like to invite you and other members of the committee to visit any of our storage facilities in the United States. Happy to take questions. Thank you.
Okay. Thank you, Mr. Kumaraswamy. Let me address my first question to Dr. DeWitt and Mr. Kumaraswamy. And it is this: what regulatory hurdles did you face, and what do you suggest Congress do to address those regulatory hurdles? And Dr. DeWitt, we'll start with you.
Thank you for the question. We're actively in that process right now, and we have a long road ahead of us, frankly. The nuclear regulatory process is it's an ongoing and sort of everlasting process once you are commercializing a technology and putting it to field into market. There's been a lot of concerns historically about the readiness for the Nuclear Regulatory Commission to handle advanced reactors. We've found that that's generally been overstated and that they've been well prepared. In particular, recent activities around working with DOE to prepare for what are called advanced reactor design criteria, as well as other efforts the NRC has undertaken to prepare themselves technically to review advanced reactor applications are paying dividends as we speak. Our formal interactions with the regulator have gone quite well so far. However, there's still room to improve. And I think a couple of those areas focus on right-sizing regulations for reactor size and potential risk, and also right-sizing security and staffing requirements. That still needs to be done. So there's still opportunities for improvement, but generally we've been pleased.
Okay, good. Thank you, Dr. DeWitt. Mr. Kumaraswamy.
Thank you, Chairman. Like I mentioned in my opening remarks, I think one of the key things in the power sector is that you have market rules that are put in place for technologies that were prevalent at that time in the marketplace. And these are commonly tailored towards traditional generation facilities. And one of the concerns that we have is that when you have advanced technologies like energy storage that are trying to get into these regional power markets, those rules don't apply directly to them. So they have to be changed in order for you to allow for the capabilities and performance characteristics of these devices. So just to give you an example, Indianapolis Power and Light, which is an AES company, which is in the state of Indiana, we have had difficulty integrating a new 20 megawatt battery energy storage project in the regional market, mainly because of the fact that the power market rules in the Midwest Independent System Operator are not set up to handle the characteristics of energy storage. And so the Federal Energy Regulatory Commission is doing a great job. They had that notice of proposed rulemaking to remedy a lot of these issues. And I think encouraging those efforts to completion as quickly as possible once FERC actually gets the quorum would be a pretty important step for us to make sure that the technology can be brought into the market and the market can realize all of those benefits that the technology provides.
Okay, good, thanks. Dr. Sant and Dr. DeWitt and Mr. Kumaraswamy, do your technologies reduce carbon emissions? And if so, can you quantify it? But first of all, do they reduce carbon emissions, and is that significant? Dr. DeWitt, Dr. Sant, let's start with you.
Thank you, Chairman Smith. Yes, they do. I should point out the way our work is really set up, what we're trying to do is reduce the carbon dioxide emissions that are associated with cement production. So we're trying to create replacements for Portland cement, which, like I pointed out, provides about, give or take, 9% of global CO2 emissions. Being able to reduce the CO2 footprint associated with cement production by avoidance and by taking up CO2 by utilization, both yield reductions in carbon dioxide. However, we should be careful to point out that this is a small number, so we're talking about a few percentage points. It's a big number if you look at it in terms of the potential reduction that you can achieve, but in the grand scheme of things, it's still only a few percent.
Okay, thank you, Dr. Sant. And Mr. Kumaraswamy?
Sure. Energy storage definitely has the capability to reduce the environmental emissions that we have. It's also notable that the U.S. electric grid currently has less than 1% of energy storage in the system. That's equal to about 20 minutes of the total demand that we have for energy in the country. Mm-hmm. This is in comparison to about 4 days worth of storage that we typically find in other networks, like gas networks, and significantly more storage that we have in things like data networks. Mm-hmm. So just a point that the amount of energy storage that we have in the system is significantly lower in the energy system. By increasing the amount of energy storage that we have in the grid, we can make sure that we integrate all of the renewable energy sources that we have on the system, and most importantly, help operate the existing conventional generation resources much more efficiently, right? Instead of cycling them back and forth, you actually get the capability to operate these existing generation facilities at more stable output blocks, which means that they actually produce lesser emissions. Okay. And you reduce the amount of renewable curtailment also, and so there are significant environmental benefits with energy storage.
Thanks. And Dr. DeWitt, briefly, nuclear is obviously going to have a huge impact on carbon emissions. Can you explain why and how?
Yes, it has a huge impact on reducing CO2 and other emissions because it doesn't produce any during generation, and it has a massive scalable potential. One single fission event produces 50 million times as much energy as when you combust a single molecule of natural gas, so you can avoid a lot of emissions. Look at France and Sweden. They have some of the best track records for decarbonization, solely due to nuclear, frankly.
Okay, thank you. Appreciate your answers today, and Ms. Johnson recognized for her questions.
Thank you very much, Mr. Chairman. Dr. Venke, we have heard from scientists and policymakers alike that there is often a false boundary drawn between basic and applied science. To some, supporting basic research is an important role of government, while applied research should be left to the private sector. Yet this idea that there is a line that neatly divides the two separate levels of research is not realistic, and certainly goes against general understanding of scientific discovery and innovation. As you mentioned in your testimony, you have written extensively about this issue. Would you agree that with this characterization, or do you really feel there is a distinctive line?
So, thank you very much, Honorable Minority Leader. I want to really emphasize that historically, this divide started during World War II and before. But really, many scholars, not just me, including economists, social scientists, have done studies and have showed that this is a false dichotomy. And in fact, you have to actually fund all aspects of research to be effective. My own work, which really was modeled after Bell Labs. In fact, I looked at the original speeches of the Bell Labs. They were such an iconic institution which did such great science and such great technology. They made an explicit point of not breaking research up into parts. In fact, the leader of Bell Labs had arguments with Vannevar Bush on that subject because he said, we do not separate them because, in fact, discoveries and inventions feed on each other, and there's both back and forth. So my argument is research does need some insulation, but not from engineering and technology. It is about the long term. It is about the somewhat unpredictable, unscheduled. Nobody predicted the shale gas revolution would happen by that research, as an example. Same with nuclear fission. Same with solar cells. So the point is, the longer-term work, the federal government has an extremely important role, and it must involve science, technology, and engineering intimately linked and not separated. And that's, in the Department of Energy, the way this has been separated has been a severe hindrance, in my view, in terms of stovepiping. As I mentioned, even NSF realized in the 80s through a corporate lab director, Eric Bloch, to create these interdisciplinary centers, including engineering research centers. So the question to ask is, how are the energy innovation hubs, like the science and technology centers and engineering research centers, which is missing in the Office of Science?
Thank you. Any other witness would like to comment on that?
I would, please. Thank you. I think it's one of the interesting things about the commercialization that we're working on towards nuclear, with metal fuel specifically and advanced reactors, is it opens up the pathway to continuous innovation for improvements that we've discovered along the development pathway already. It's important to never lose sight of that and not to think that something is just ready, because it's still at some of those stages that you discover new things to do. Those are still too early for commercial readiness, and it's important to have an awareness on that, and also to maintain that perspective that once you get something ready to go for commercialization, that doesn't mean innovation is done. There's still opportunities and pathways to bridge on that.
May I add something? So you can argue how far in the innovation chain one should fund, and we can discuss that. This is back to the ones which are at the late stage, and that's a legitimate argument. I would say it depends on the situation.
Dr. Menke, the President's budget request declared some research as early stage and therefore worthy of federal support, and other activities as later stage research that should be immediately eliminated, given that the private sector is supposedly better equipped to carry this research out. However, the administration officials recently confirmed to committee staff that they did not engage with the private sector at all while compiling the budget request to determine what industry would be able to or willing to pick this up. In your experience, are the cuts proposed for the fiscal year 2018 budget research areas that the private sector is willing to simply start funding after the federal government cuts them off?
This is an extremely important question. I personally feel, I think there is not good data on that anyway, but the private sector today in the United States is just not doing the longer-term work because of the risks involved. And that's one of the reasons, in fact, because of global competition and others, while other countries are beginning to do more of that because of state support. I'm going to go to a meeting of the National Grand Challenge Summit right now, which actually involves UK, Europe, and China. So the point is, our companies are not doing it, not in every industry. IT is still, I think Google, Microsoft are doing some, which is very good, but in the energy space, that's definitely not true. There is evidence, on the other hand, if government makes the investments, eventually it feeds into the private sector, as is true for the shale gas and several other cases. But what is really quite important, I think, is there does need to be, like our engineering centers, our energy innovation hubs, ARPA-E, must involve consultations with the private sector. We do want to have them involved in that discussion so we can actually think about, when we made our energy plans in the book, which I co-authored with two of my colleagues, we actually interviewed a lot of private sector people where they thought the investment should be made. So I think, because they want the long-term investments, so I think we want to involve them in the discussion as well. It has to be a cooperative thing. As I said, technology transfer is a body contact sport.
Thank you, my time.
Thank you, Ms. Johnson. The gentleman from California, Mr. Rohrabacher, is recognized.
Thank you very much, Mr. Chairman, and thank you, Mr. Chairman, for taking the leadership and calling this hearing today. We need to have discussions like this on basics, and your leadership is certainly making sure that we get that type of discussion. Let me note that to our witness who was mentioning about the, Mr. Sant, who was mentioning about the U-turning of CO2 into useful material, and we compare that to what I consider to be a sort of an irrational approach to try dealing with CO2 and just trying to eliminate CO2. You're suggesting that we actually can use CO2 in a way that will be beneficial to humankind and making a profit out of extracting it. Now, let me note that you're talking about cement. There is a company in my area, New Light, that has developed a methodology of, and they have a process now working that takes CO2 out of the air and turns it into plastic, high-quality plastic. And I think that we are going to find with research that instead of going about the regulatory and trying to stamp out the use of CO2, we're going to find it's much more effective for mankind to find useful purposes for CO2 that we can actually extract it from the air, that we don't have to worry about the debate as to whether CO2 is a pollutant or not if you actually have people using it for positive ends. So, number one, I thank you for your testimony today. I didn't know about your uses that you're suggesting that are available, and I think it deserves a lot of attention, so thank you. What also deserves attention, as far as I'm concerned, is the future of nuclear energy in this country and throughout the world. Nuclear energy we had such great hopes for it, but it should be evident to anyone now that the former light water reactors, the initial move on stage in the nuclear arena is extraordinarily dangerous. We have closed down San Onofre in my area, and rightfully so, because there are dangers involved with light water reactors. Mr. DeWitt, does what you're trying to develop now in the nuclear energy field, does that have the same dangers?
No, very different safety profile. It operates purely on natural forces. It's very passive. It has low pressure. And basically no pressure operations. So it makes it a very safe profile in terms of what it can do and behave at.
Can it melt down and release radioactivity?
Effectively, no.
So we have the capability now, Mr. Chairman, to actually do this. We've had this capability for a while, and we have instead been, well, for whatever forces at play in our society, we have been channeling resources into developing nuclear power plants that have extreme danger associated with them. And now we should understand, and the testimony today highlights this, that we should focus on our alternative, making sure the alternative that we have, which is a nuclear energy source for electricity that is far less dangerous, if not dangerous at all, we should make sure that that comes to play. And that's right through this committee. This committee will do the things that are necessary to make sure that the next generation of nuclear power, which is safer, that we get into that new generation as soon as possible. And when we're talking about that as soon as possible, do you see, Mr. DeWitt, do you see the fact that the small-scale programs, and perhaps like your own, which were provided technical support and lab capabilities, you think is that a better way for us to approach this than through large grants through the license to try to move things through the regulatory process?
I think in general it has substantial benefits for where the industry is now. And I think it is a better way because I think what we've seen is we've had very high impact and high leverage outcomes from a very small amount of money to date, much more efficiently than you would get with a large cost share program at this stage. That doesn't mean that you can't have those down the road for demonstration type purposes, but I think it's a better use at this stage.
And one last thing, Mr. Chairman, I think that it doesn't really make sense for us to be funding big companies to help them move through the licensing process, which is basically a federal process. So we're giving grants to people to help them deal with the federal agencies, and instead we should try to reform the federal agencies so that they don't have these impediments to this type of progress. Thank you very much again for your leadership, Mr.
Thank you,
Chairman.
Mr. Rohrabacher. And the gentlewoman from Oregon, Ms. Bonamici, is recognized.
Thank you very much, Mr. Chairman, and thank you to the panel for your excellent testimony. Dr. DeWitt, I want to thank you particularly for mentioning in your testimony NuScale Power, which is, of course, headquartered in Northwest Oregon in the district I'm honored to represent. And also thank you for mentioning the role of the national labs and the Department of Energy in your work over the years. I really appreciate that. Mr. Kumaraswamy, thank you for talking about energy storage and your work on energy storage and the potential from modernizing the grid is something that I've had many conversations about back home in Oregon. In your testimony, you say that the national labs through the Department of Energy are doing a great job in advancing the modeling and visualization of benefits that energy storage brings to the grid. And you go on to say that the government should encourage and increase investments in the Department of Energy and national labs to continue this work. Yet we are now looking at the Trump administration's proposal, which has significant cuts to the Department of Energy. They seem to be ignoring recommendations from industry experts like you. And for example, the fiscal year 18 budget proposes to eliminate the Advanced Modeling Grid Research subprogram that's within the Department of, within the Office of Electricity Delivery and Energy Reliability. I know that administration officials recently confirmed that they did not engage with the private sector at all when determining which Department of Energy R&D programs they would be cutting or eliminating. So could you comment on what the consequences would be of cutting research and development programs like that one that provide us with the capabilities that you mentioned are so important in upgrading the grid?
Sure. I think one of the hallmarks of commercializing new technologies like energy storage and bringing them to market is making sure that the needs of the system and the benefits of the technology can be understood and appreciated by all of the stakeholders. And so just to ground that fact, maybe I can offer an example of one of the early instances when we actually deployed energy storage in the marketplace. This happened to be in the Mid-Atlantic region of the country in a market called the PJM Regional Transmission Market. And this was largely made possible because of the fact that the market made the need completely known to everybody that was involved in that place. And so, it was a need that was oriented around frequency management and the role that energy storage could play towards addressing that frequency management issue and provide all of the service and for all of the stakeholders to evaluate those benefits. The tools were available for that. And so I think that's the key part towards commercializing new technologies. And other parts of our electric sector where we don't have organized electric markets, like in the PJM market or portions of the Northeast, I think the need still remains pretty obscure, right?
Thank you. And I do want to get to another question. Thank you very much. Dr. Venke, the Trump administration released its budget proposal for fiscal year 2018, and the research and development funding levels, as I mentioned, for the Department of Energy are woefully inadequate. And the president said he wants to usher in an era of American energy dominance, yet he's simultaneously proposing to cut and frankly devastate our energy research enterprise. So that's not the path to a stronger America. It's a path to energy reliance on international, sometimes unstable competitors. So does the fiscal year budget proposal set us on a path toward energy dominance, and will the private sector be willing and able to fund the research that will no longer be funded if these budget cuts go into effect?
Thank you very much for that question, because I think you're right on. In fact, many of the things mentioned, including nuclear power, Idaho Nuclear Laboratory, or National Renewable Energy Laboratory, which does a lot of test facilities for many of our things, they come from the so-called applied offices. And these are extremely important test facilities which are vital for the national interest. Second, in fact, this early stage technology research is not being done by the private industry. As I said, we do want to involve them. There need to be cooperative research and development agreements, but in fact, we will become second class. From what I see in my role, both as Foreign Secretary of the National Academies and continuing looking at what is happening in China and other places, that technology is moving forward, and we need to be at the leading edge.
I agree that
I cannot accept this.
Dr. Venke, the energy efficiency and renewable energy would receive a 70% cut, and some of the activities would get an 80% cut. Oregonians are leading the way with some of these technologies. What would be the consequences of drastically reducing that research and development for U.S. competitiveness in a global economy?
We will not be protecting our future. As an American, I came here during the height of the space race and the role of technology, how important was. I'm passionate about technology. It is politically agnostic. It really will shape our future. Even electric cars, that horses run out of the barn. It's only 2% today, but longer term, people will learn to make it cheaper. It'll be much more efficient because the engine is much easier to maintain from simple engineering. The same reason shale revolution happened, because natural gas is cleaner and cheaper than coal. So it behoves us. People talked about nuclear. Nuclear is extremely important. And I think for this committee, it's important to know that no matter what happens with renewable and others, the electricity grid is going to need base power, at least 20% base power. So we will have to have it to come either some kind of natural gas or nuclear or some other, maybe even coal, clean coal where you capture it. So we want to protect that. It has to be diversified and heterogeneous, and we should be advancing even the nuclear technology so it becomes safer, more cost-effective, et cetera, and doing that kind of research, I personally think is still valuable.
Thank you, Dr. Venki. I see my time has expired. Thank you, Mr. Chairman.
Thank you, Ms. Bonamici. And the gentleman from Texas, Mr. Weber, is recognized.
Thank you, Mr. Chairman. My goodness, so many questions here. Dr. Venki, I'm going to come right back to you. You said 20% base power backup, whether it's clean coal, whether it's nuclear, whether it's natural gas. How did you get to 20%?
I think people have done grid work and figured out from statistically what will happen, so you know that you need this. You will need some base power. People who know how to manage grids will tell you that you've got to maintain for stability, have a certain backup of steady power.
That seems low to me because that's 1/5 of the power required.
Somebody may say it might be a little higher. Certainly, it's going to be required.
Would you agree that it's better to have more power than less power?
It's always good to have. I believe in safety.
Okay, and you believe in clean coal technology?
If clean coal can be done, so one of the options, technology must provide options. And so when you have one of the areas where long-term federal funding might be valuable is, in fact, for carbon capture and storage, if you can actually make use of the carbon, which is even better. So I actually want to keep those options open, including for large investments, for certain cases, because options is what the technology is about.
Well, certainly they are, and I would say the higher percentage is the best option there.
And then there are many global countries which are dependent on those. They might have to have some global implications, which might help the overall even carbon.
Was it Theodore Roosevelt who said, speak softly and use nuclear as backup? I'm just
Sorry, I get excited.
Just asking.
Yes.
Dr. DeWitt, this question is for you. You were a strong supporter of our nuclear energy legislation, which passed the House 3 times last Congress. You alluded to that. And again, earlier this year as part of the DOE Research and Innovation Act. What could the policy, obviously you're tracking that bill and paying attention, what could the policy in that bill, including the construction of that versatile neutron source, provide to you and other advanced reactor companies? Would you elaborate on that for us?
Absolutely. Thank you for the question. That legislation is incredibly important because it enables, one, it opens up the opportunities and streamlines the processes to work with the national labs and take advantage of their infrastructure and capabilities. And it also, of course, paves the way to provide new capabilities with a versatile neutron source or a fast test reactor, which will accelerate both the development of new fuels and materials so that we can get to market more quickly with these technologies and discover entirely new things that we don't even know about today because we don't have those capabilities that a facility like that would provide.
All while working with the regulatory agency that would be involved in the process.
Absolutely.
Which would help expedite that process.
And that's critical to it because they need to learn from it and we can all learn together, frankly.
You betcha. Now, you also mentioned that France and Sweden had done a really good job of reducing their carbon. Do you know percentages and timeframes?
Generally speaking, France decarbonized pretty substantially in about 15 to 20 years. They effectively went to 80% nuclear-based power sources, which reduced their carbon emissions by a commensurate amount. Sweden was a similar time frame and a lesser but a similar impact. It wasn't quite the 80% deep
Is
dive.
France still at 80% today?
They're a little less just because they haven't been building as many nuclear plants, and unfortunately they're moving to shut some down, which is a terrible mistake.
Okay. And do you know the grid size, per chance, of each of those countries?
I do not, but I know that they are smaller, of course, than the U.S., as it is. But off the top of my head, I think the French grid is somewhere slightly smaller than Texas.
Okay. You were vocal about how, is it Oklo, is that how you say that?
Yes, sir.
Oklo is funded through private investment, but this is not the norm for innovative nuclear companies. Why did you choose that model?
Because that gave us a pathway to get to market quickly. It also gave us a control of our own destiny. So we weren't at the whims of either a project manager at some agency or the political whims, depending on what was going on, of the government. It gave us insulation from that. It also gave us the ability to focus on what the market wants and not have to cater to what perhaps a grant maker wants.
Refresh my memory, how long has the company been in existence?
We launched in 2013, and so it's only been about a little over 4 years.
And where are you located?
We're in Sunnyvale, California.
Sunnyvale, California. Okay. Mr. Chairman, I'm going to yield back.
Thank you, Mr. Weber. And the gentleman from California, Mr. McNerney, is recognized for his questions.
Well, thank the Chairman. It's a good hearing, and I'm enjoying listening to your testimony. I think it's pretty bipartisan, and I look forward to continuing this discussion. Dr. Vanke, would you describe the valley of death for technology and how the government could play a role in that?
Yeah. So there are, of course, as you know,
Your microphone?
ultimately, sorry, I didn't turn, and I'll try to speak more softly. I tend to get excited.
I can understand that.
I would like to say that it's good to have passion, though. You should care about it, and I care deeply about us being number one. And my Bell Labs past taught me that we always have the leading edge.
Valley of death.
Yes.
Question.
So, very early stages, if you take the transistor, the original transistor was a total kludge. Nobody ever thought you could actually make circuits out of it. So the first phase is to sort of make it something which you can actually make at least a few of. So that's the first value of death, to actually where is this just a good research curiosity and not really any technology. As you learn how to do this, there are, of course, various stages where you may decide to turn it off. The big value of death comes a little bit before manufacture, because then you have to literally make millions of them and actually invest a lot of money in it. So it's a question of the investment when you go up in scale. So those two valleys of death are particularly the important one. And the first one, there's no clear question that we have a role. That's exactly what ARPA-E or Energy Innovation Hubs, et cetera, do, or engineering research centers. The second one is for the very large issues. And there, you'll have to argue where is the appropriate government's role. At the Harvard Kennedy School, when I first became Director of Science, Technology, Public Policy Program in 2011, we convened a very large group, including a lot of people from industry and a lot of people from government and academia, to debate the government's role. It's actually there, that report, and there's not uniform agreement. But everybody agreed for some particular ones, it might be turned out because it might be in the nuclear case, it might be in the carbon capture or storage, where there's a huge public goods aspect, where in fact we must have the option, should in case something happen, including clean, and coal is an important commodity worldwide, that maybe there is a role, and then should there be some joint thing. Everybody agreed, including the industrialists, there were some important points, that this thing should be steady. We cannot let it be just simply political, i.e. it is a failure. Second, the companies must have a significant skin in the game. They must have something like 50% skin in the game, large skin in the game, and you can find those. That was the view of this workshop which I held. And of course, some people, you may say, for some things, we don't have a role. The private companies should take it and they should spend the money.
Thank you. Mr. DeWitt, in your opinion, does the fiscal year 2018 budget proposal set us on a path toward energy dominance?
I don't think it does. I think there's more we can do, absolutely. But I do think there are some good signs in there. Particularly is the appropriations for a fast test reactor. I'm supportive of that, but I think we need to not lose sight of the fact that if we really care about dominating in the global space, the rest of the world is investing heavily and massively. We cannot lose sight of that, and we have to pay attention to that. But we also have to be focused and mindful of what the markets are wanting and needing, and not just in the U.S. And that's something that I think sometimes there can be a focus too myopically on. We need to look worldwide and how we can compete globally.
Could you discuss how federal investments in nuclear R&D have paved the way toward your companies to succeed?
Oh, absolutely. That's a cornerstone upon which we're building and all advanced reactor developers are building. That's an absolute fundamental necessity that we are thankful was invested in.
Thank you. Dr. Venke, again, the Department of Energy has 4 energy innovation hubs, and they're establishing a 5th one on the cross-cutting issue of the energy-water nexus, which was supported by last Congress. Do you support the use of continued use of this model, especially with regard to the energy-water nexus?
Yes. I mean, unlike ARPA-E, which I've looked at in detail in my research, I know the energy innovation hubs. I know the one at Argonne, which is run by George Crabtree on storage. I actually think it's a very important model. The full impact will only be known about 10, 15 years down the road. But we know from history, from what NSF has done and what Department of Defense has done, that these will be very valuable. So it will have to be a balanced portfolio, and there do need to be certain critical areas where you actually combine strengths. Industry should be involved, as well as the national laboratories and academia. And I actually think it's a very good model, one of the different ways of doing it.
Thank you. Mr. Chairman, my time went too fast. I'd like another 5 minutes.
Okay. Thank you, Mr. McNerney. The gentleman from Illinois, Mr. Holmgren, is recognized.
Thank you, Mr. Chairman. Thank you all so much for being here. This is an important hearing, and grateful for your work. And it is so important for us, especially as the committee continues to look at ways in which the DOE can better assist the private sector as they do what they do best, innovate and bring new products to the market. Seeing firsthand how the national labs work at Fermilab in my district and Argonne, just outside of my district, I've been able to see why the labs and our user facilities are often referred to as the crown jewel in our research ecosystem. I was glad to see stable funding for these facilities in the Energy and Water Appropriations Bill the committee just reported, and I'll continue to keep fighting to see this in the final bill as well. I wanted to address my first question to all of you, if any of you have comments on it, and wondered if you could just let us know in what ways did you specifically use federal funded research infrastructure like user facilities at the DOE national labs to develop your technology, and what other facilities should DOE be looking at, and how could we change the operating practices of the labs to make them even more accessible to small business and startup developing innovative technologies?
When I was at Bell Labs, we did much of our research work in supporting, for example, light source facilities at Brookhaven National Lab, at Argonne National Laboratory, as an example, because they are extremely important. And then when I was vice president, of Sandia, we actually created for lithography, where one can use some of these light source, teaming with Lawrence Berkeley Lab, et cetera, to advance lithography techniques. Those are these large facilities, including run by the Renewable Energy Laboratory. These are all extremely important, including high-performance computing at Fermilab, at Argonne National Laboratory, and we still use them even in academia, as in fact, especially including the computing facilities. So test facilities are a crucial role and extremely important.
Thank you. Anybody else?
Yeah, I could offer a comment there. I think one of the key areas that's been pretty helpful from the national lab side has been looking at the benefits that storage brings to the grid. I think there's significant research that's being done by NREL, by PNNL and Oak Ridge Labs and many of the national labs towards establishing all of the values that energy storage bring to the grid, right? And so I think that's a cornerstone for us to make sure that all of the stakeholders that are involved in some of these key decision-making processes are able to appreciate those benefits. And like I mentioned in my testimony, I think it's one where the private sector can significantly benefit from that type of research and computational models that are deployed at the national labs.
I'd be happy to. We've benefited tremendously from the decades of research and development that Argonne led in advanced reactor development, and we're actively working with them now in the capabilities they and Idaho, as well as Sandia and others have. And the GAIN program has been tremendously helpful in streamlining access and partnering.
I'd like to follow up on that, if that's all right, Dr. DeWitt. As you said, Oklo participated in the Gateway for Acceleration, Innovation in Nuclear, or GAIN program, which provides the nuclear community with access to the technical expertise at the national labs in order to commercialize these new technologies. I wondered, do you think these small-scale programs that provide access to technical support and lab capabilities are a better investment than providing large grants to move through the licensing process?
In general, at this stage in the advanced reactor industry, I do think they are more effective. I think as the industry grows and matures, it's valuable to revisit that. But the impact that you can get and the return effectively on investment that you can achieve with these small grants that are targeted across a broad spectrum of areas, they yield really high impact results for very little money. What we've done with a few $100,000 has frankly been phenomenal in our mind, as well as the mind of our investors. Very high impact.
That's great. Dr. DeWitt, sticking with you, does working with DOE improve or slow down the process necessary for startups like yours to create and implement innovative technologies? What policy changes can be made at DOE to make their engagement with the advanced reactor community more productive?
Yeah, I think the answer is there's benefits and drawbacks at this point, and we're learning. Both parties are learning on how to do this better and more efficiently. Contracting structures are being modernized and updated, and general interaction mechanisms. And GAIN is very helpful in streamlining that process and identifying issues and helping address them. But the biggest single issue is DOE lacks the sense of urgency that the private sector demands. Unfortunately, in nuclear, we've gotten complacent in the industry. Like the pace of nuclear compared to the pace of our Silicon Valley peers is order of magnitude different. So we're trying to accelerate that, and DOE needs to, I think, recalibrate that and continually strive to be more urgent in what they do.
Is there anything we can do to help with that?
I think one of the issues has been helpful, I think, that you guys have done and will continue to do is through, frankly, Congressman Weaver's bill to open up access to the national laboratories and be able to partner with them in different opportunities or different ways, both as user facilities as well as possible demonstration facilities. That and the impetus that provides, I think, is a huge opportunity to help address that issue. And otherwise, continually revisiting that challenge and seeing what can they do to be faster and more efficient interacting with the private sector. It's just a constant learning process.
Great. My time's expired. I'd love to follow up with you, but I need to yield back my time.
Thank you, Mr. Holmgren. The gentleman from Colorado, Mr. Perlmutter, is recognized.
Thanks. And Mr. Holmgren on that side and Dr. Foster on this side like to talk about their labs in Illinois. They're like Illinois Chamber of Commerce, okay? So I want to talk about my lab, and I want to start with you, Mr. Kumaraswamy, the National Renewable Energy Lab in Colorado. And if you could talk about the way that lab assists you and others in making sure this technology that is being developed really is valuable to the citizens of this country. So if you could start there, sir.
Absolutely. I think they're doing some fantastic work at the National Renewable Energy Laboratory. We are grateful for that. One of the key areas of focus for us at AES is the application of using energy storage for peaking applications. So when we think about the country actually needing significant amounts of generation capacity that would run for a fraction of the time in a year, right? That's what we're talking about when we talk about building new peaking gas plants. We think that energy storage is an extremely cost-effective alternative for building those peaking gas plants. And that's an area that we have continued to benefit from the NREL type of studies, right? Because one of the areas of research that goes on at NREL is to make sure that you actually look at the benefits of using storage for that peaking application and produce those type of high-quality reports based on solid analytics. And that helps us pursue these conversations regionally and nationally across many different stakeholders.
Thank you. And, you know, Dr. Venke, you were talking about clean coal and nuclear and, you know, natural gas, you know, a couple of the others. And I think we need to have a whole diverse approach to our energy production. And so I have a slide up there which just shows NREL working on photovoltaics, you know, starting back when the lab started at $76 down to about 30 cents, and there are some tax credits involved. And, you know, part of what we're trying to do as a country is to provide it cheaper and better and less polluting as possible. So talk a little bit about that continuum of research.
Yeah. So thank you very much for that question. Actually, NREL is a laboratory where another postdoc of mine spent significant time looking at their portfolio and analyzing and talking to people. First, I want to mention that we have not given a consistent, somebody asked, how can this help? That technology transfer is an important mission and that we are proud of it. So NREL actually developed the first technology which led to first solar. And First Solar is among the few highly successful U.S. solar companies which are not in China or Germany. This is extremely important, and we should be proud of it. And we should actually celebrate it because it came. The cost of solar, of course, has been coming down very significantly and producing a lot of jobs. We talk about the jobs, and these jobs will be there no matter what. And the energy system is going to be heterogeneous. It is going to require things like solar, as well as storage, as well as natural gas. You're not going to get rid of all of it in day one. It'll evolve depending on circumstances, on geography, natural resources, etc. It's a worldwide issue. So us working in this leading there, but however, the way the DOE also needs to make this as an important strategy and can make it simpler. But certain things, the NREL lab directors and the laboratory people should have greater discretion of working across that boundary under some proper guidelines so that it's open and fair and those matters. So sometimes it can be more interfering the way the Department of Energy might run it. I think developing a coherent policy there would be valuable to help NREL.
Thank you. And Dr. Sant, so high school, college, law school, I worked for a precast concrete company. And I was in the laboratory, and we do the cylinders and then crush them and see how strong they were based on different things that we added. So talk to me a little bit about how strong this concrete, using a byproduct that could be a pollutant or could be a real substantial ingredient. Tell me how strong this concrete really is.
Good question. So, in fact, about 65–70% of all concrete in the world that's cast, so to speak, has a strength on the order of, let's say, about 30 megapascals, right? So that's the kind of stuff you'd use to build a house. The stuff that we're producing is well within that territory. So there's clearly a large accessible market you can reach out to. I will be careful to point out that we're not trying to look for opportunities to build 100-story buildings. We're looking for opportunities to build everyday construction, which is really where the large volume of construction is, buildings as an example. It's also important to point out exactly in that spectrum that there's a unique opportunity here because, as I'm sure you're well aware, the construction industry is not really very tolerant of cost escalation. We like the lowest bid. And I think one of the opportunities that comes about with what we're doing is we seem to have a real line of sight to being able to produce something that's cost competitive as is, which is an important part because that's how you'll start to get penetration and diffusion.
Right. Thank you. And I yield back to the chair.
Thank you, Mr. Perlmutter.
If you give me a moment to get prepared after the move here. And now I'll recognize myself for 5 minutes for questions. That was convenient, wasn't it? Yeah, Dr. DeWitt, I'd like to kind of follow up on something that you mentioned when you were having a discussion with Mr. Webster, or Weber, I'm sorry. And you talked about stability, and it was a stability in where the government may be, what the reaction of the government is, and the lack of stability going forward when it comes to research and development. And I think that really hits upon a problem that we're facing today because politics is 90% emotion and if we're good, 10% logic sometimes. And I see you laughing because it's really, we're seeing that play out right now on the other side of the Capitol. But historically, we've had agencies and other elements of government that had been that buffer between the whims of politicians and the science of research and development. They were that element that was there that focused on handling the politics on our side, but buffering that from the research and development element of our society. The problem I see now, from my perspective, is that the political drive has filtered into those agencies, that there seems to be a political element now within those agencies, which we didn't have as much in the past. And some of that comes from talking with some of our research institutions in Georgia. I recently visited one of our research institutes. Well, I've visited in the last couple of years several of them, and I asked the question, where do we need to go? What do we need to be doing? And there's two things, especially when it comes to grants, that we're continually hearing the same concerns from our research institutions. It's twofold. One is the cost to manage the grant is going up, is extremely high. Some up to 20% and even more spent of the grant money spent just on administration of the grant and reporting. And I'm seeing that is pretty consistent. And the other is that there's too much emphasis on short-time successes. In other words, there's no room for failure anymore, but failure is part of the scientific process. I mean, if Thomas Edison was receiving a modern-day grant, he wouldn't have invented the light bulb because, as he said, his failures were 10,000 ways to prove something didn't work. So, Dr. DeWitt, and I'll expand this out to others on the panel, do you do you see that? I know you're dealing with the private sector, and it makes me think that maybe that's some of the reason why you're not going to the government for funding, if you would opine on that.
Of course. Thank you for the question, and I think that's a very real situation. We recently made some decisions at Oklo with our investors and our executive team not to pursue certain federal opportunities for funding because the costs of managing that were too high. They just simply weren't worth it. And the other part of it is often those can be targeted in a scope that's, like you said, so risk averse that it's focusing merely on near-term objectives that really aren't moving the ball forward, or they're not even looking at opportunities for finding like impact in the market specifically. And as a result, you can kind of just miss the entire objective altogether. And I think that's a very real challenge today.
Okay. Dr. Sand, I noticed you were nodding at part of that. Would you like to?
I think that is right. You know, very often I think a lot of calls end up being very narrowly focused, which means that you've got to conform to a pretty narrow spectrum of ideas that you can potentially look at. And also, given the fact that there's limitations in how much risk you can take, that turns out to be problematic. But I think the part which also turns out to be harder is grant timelines turn out to be rather short. I know that most of them are 3 years, if you're really lucky, 5. And very often, sustained work just needs much longer grant durations than that, without an annual review deciding your fate, so to speak.
Yes, Doctor.
A couple of comments on the same point. The energy innovation hubs, et cetera, energy frontier research centers are partly aimed at that longer-term issue. That is, they're 5-year funded or 4-year funded, same with the NSF, to encourage that, and some of that needs to happen. I think appropriate for this committee, since a lot of it's sort of energy, the Department of Energy has been studied a lot, including the management of the national labs, which are our crown jewels, and the Senate committee, CRNEL, has made recommendations, including how the costs in the DOE might be minimized, et cetera, which would be quite important in tackling the kind of problem you're asking about, in fact, the reporting requirements, et cetera, which would ease some of the burden and get more effect for the actual work being done.
Well, thank you. And this is something that has been a passion of me, is reforming our grant system to reduce that cost so more of the money will actually go into the research and development, and also allow for longer term, because failure is part of scientific research. So thank you all for being here. This time the chair will recognize the gentlewoman from Hawaii, Ms. Hanabusa.
Thank you. Thank you very much, Mr. Chairman. Dr. Venki, I am a great fan of DARPA. I've sat on the Armed Services Committees for years, and DARPA, in my opinion, has been one of the best hidden secrets that the Department of Defense has, especially in terms of its ability to innovate and its structure. Some have described it as 100 geniuses running all over the place with a travel agent kind of moderating. So it doesn't have the usual bureaucratic structure that we think about. You have testified that you've spent a lot of time looking at the structure of ARPA-E, and as you know, in the Trump budget, his proposed budget, there's only about $20 million, and it's really to transition the demise of ARPA-E. Can you first tell me, from your perspective and what you know about how ARPA-E operates, its importance and its significance, as well as the kinds of research that you can point to that have been actually very critical for the Energy Department?
Thank you very much for asking that question. I feel quite passionately about ARPA-E because it was a very important innovation in the Department of Energy. You know, we all value peer review. Peer review is important, but it has its limitations because it leads more to the average. And so ultimately, you need program managers who are technically savvy, got to know the people and the work which is being done, and will consult. Obviously, you cannot just do it arbitrarily, but try to actually pinpoint high risk and high reward, where they will ask the people who are evaluating, rate them on the very high risk part. And then they would look at that, taking an average, they would look at that distribution and by judgment make some high risk. And that's what DARPA does too. So it's an important innovation in the management system where you combine some good aspects of peer along with judgment, ultimately is judgment, and especially with regard to high risk. The other thing when we looked at many of the awards, my postdoc looked at some 4,000 awards which were given by ARPA-E. We should remember it's still early, it's only 5 years old. But what we found, that there was many scientific papers which were published in leading journals like Science and Nature, and their impact was similar to that published in the Office of Science, and yet there were a large number of patents. There were very few patents from the Office of Science. So that tells me ARPA-E is not being negligent in its science, but is also developing new technology, i.e. the other is a missed opportunity. So I am very positive on that aspect. And then at this early stage, there are some examples. The National Academies recently issued a report. I didn't know that. There's a colleague of mine at Harvard, Joanna Eisenberg, whom I hired a long time ago. She has developed some very nice biomaterials which actually now are going to the market. Also was a Nature paper. Another colleague, advanced storage, battery flow, which is also a scientific as well as leading to a company. There's another one from Santa Barbara, Transform, gallium nitride electronics, and people talk about the leverage. Because ARPA-E had shown this, there has been much greater private investment. It was like a stamp of approval that this technology is moving forward, and Transform has really grown. So it has taken, so there are different forms here, and the early prognosis is good, and my guess is it is a very important innovation, along with energy innovation hubs and energy frontier research centers. You do want to have a portfolio.
So what do you think is going to take its place, if anything can take its place?
I hope it does not. I hope in the end, I believe, including ARPA-E and much of this work which I'm talking, was often a bipartisan. I really believe this should be bipartisan. It is for the country. And that doesn't mean the program managers are always going to choose exactly the right one. That is not, even private people don't do it. There's always, and these are risky. But there should be some successes, and it should be bipartisan. Technology does not know political boundaries, and this will happen.
Thank you.
So I hope it does not. I hope it really is funded.
Mr. DeWitt, when Dr. Venke was speaking, I saw you nodding. Do you have an opinion of ARPA-E?
It's an interesting question. I do. I mean, we've supported different I guess, workshops, if you will, and have been rather impressed by some of the activities they've gone. However, one of the things that I think it's an early stage organization, and it's still growing in a lot of cases and still has a lot of upside. That said, it has struggled, I think, and we've seen certain struggles of it being a little too academic in certain areas. That's not always a bad thing, though. I just think it's a matter of making sure you have an organization that continues to learn, because some of these things should be able to afford to fail and learn and grow from that. That's something that we really like to see happen.
Thank you. Mr. Chair, I yield back.
Thank you, Ms. Hanabusa. And the gentleman from Louisiana, Mr. Higgins, is recognized for his questions.
Thank you, Mr. Chairman. Gentlemen, thank you for appearing before this full committee. Your combined IQ is frighteningly high, and a welcome transition from some of the things we witness in Congress. Representing a state that is recognized as perhaps the nation's leader in the oil and gas industry, I've witnessed regulatory overreach over the last decade push the American oil and gas industry to the shores of other countries. And considering the totality of circumstance of the world's ecology, my personal opinion is that a psychologically unsound logic. So, Mr. DeWitt, my question is for you, sir, regarding nuclear technology. Nuclear energy is one of the most heavily regulated industries in the United States, and we must balance the benefits of nuclear energy with potential safety risks and ecological concerns. These regulations can impede the potential for the export of U.S. nuclear technology, but we must recognize that a higher regulatory burden on exports in the United States could work against nuclear safety worldwide and security goals if it allows less regulated technologies from countries like Russia and China to reach new nuclear markets. What types of regulations do you believe, sir, are unnecessarily holding back the export of U.S. nuclear technology?
Thank you very much for the question. I'm very passionate about this issue because it's a huge hindrance to global leadership in nuclear, and it's something that we really actively as a country need to reevaluate because, like you said, our barriers we're self-imposing are preventing us from being a massive world player that we should be here, but also ceding the opportunities to, frankly, less mature and less safe and less beneficial competitors. And the reality is we need to reevaluate that at the DOE level as well as the Department of Commerce, the NRC, and the Department of State. In the last 10 years or so, there's been significant changes to the rules about export controls and nuclear that have been very detrimental. They've gone in the wrong direction. The expectations that were set in terms of exporting reactors to, for example, the UAE, when we were negotiating those deals 8 or so years ago, were misguided and have set the wrong expectations, the wrong standards that aren't aligned with what, frankly, the U.S.'s goal and the global goals for nuclear deployment should be. We need to reevaluate those, and we have to do it now because it's affecting us today.
Thank you for that answer. I concur. Would you have specific recommendations, perhaps, you could provide this full committee in writing over the course of the next month or so, whereby we may consider your recommendations, sir, as we attempt in a bipartisan manner to consider, of course, the ecological concerns of our planet, while at the same time recognizing the superiority of clean United States technology regarding energy development?
I would be happy to. American nuclear technology is the best, so I'd be happy to do that.
One more brief question, if I may. The Department of Energy has recently made improvements through its tech-to-market and technology transitions programs. However, many companies still struggle with tech transfer contracting procedures that can take up to a year to complete. From your perspective, how could the federal government streamline public-private partnerships and ease access to taxpayer-supported research?
I'll take a first go at that. I think one of the issues that we've seen is the fact that the contracting structures and the liability bases that the labs are effectively using to make their determinations are out of touch with what the objectives of the national labs really should be, to the point that they're afraid to do anything. We need to reevaluate that. It gets to a more fundamental question, I think, is what are the contracting structures for the operators of the national labs? Bell Labs operated Sandia Labs in a beautiful way, and in a way that's centered around advancing the national interest and achieving and growing national excellence. I think we've lost that today. I think it's time to reevaluate some of that so we can get back to what the core mission and the core capabilities of the labs are. I think that's one of the starting points, and there'd be some others, but for the sake of time, I'd be happy to defer those to writing.
Thank you. I would appreciate that. I believe your colleague has a comment.
I want to just second this aspect here. It is very important that the DOE is now actually having a technology transitions lab, but to do it much more strategically. And a lot of it can be done at the laboratory level, people who understand the technology closely. That was our finding with NREL. So I think reform and really recognizing it strategically would add greatly and improve our technology transfer.
Thank you, sir. Gentlemen, thank you. Mr. Chairman, I yield back.
Thank you, Mr. Biggins. And the gentleman from New York, Mr. Tunko, is recognized.
Thank you, Mr. Chair, and thank you to all of our witnesses for participating in a very interesting hearing. The only way we are going to meet our energy challenges is through investments in research and development. We cannot lose sight of the vital role that government plays in innovation. The federal government must be an active partner with our universities and certainly with our private sector. Having an R&D portfolio that covers the spectrum from basic sciences to technology development, testing and deployment greatly augments the work being done by the private sector and in the university community. And sustained support of these efforts is essential to lowering costs and improving performance of our energy technologies. Dr. Sant, can you tell us a little bit about the role federal agencies have played in supporting your efforts?
So, of course, happy to answer. So federal agencies, like I said, the Department of Transportation, the National Science Foundation, and the Department of Energy have all funded our work. It's all been funded at early stage. We're in a university. However, the important thing to point out is that we've been able to access support from each of these agencies that is really, really very strategic. It's come together to be able to address questions that are very narrow, but that we're very interested in. For example, we're interested in trying to understand how to really take building materials, which literally eat carbon dioxide. There are two parts to this. So, of course, while we look at the basic to the applied continuum, while we're working at the basic part, we need support going all the way into the applied end of the spectrum. And the reason that I say this is while we do things in a laboratory and it's easy often to realize successes, the challenge that you run into is that as you start to scale up, there are things that don't work, which require you to go back to the lab. And so you need this iterative pathway where you can stage research and funding dollars to be able to go across the entire pathway. And that's how you succeed in taking ideas and converting them into innovation and then translating them into technology. I think this is especially important to point out with conventional industries, for example, like the energy sector, the construction sector, which have very limited risk appetite, so to speak. And that's why it's very necessary for the government to underwrite a larger proportion of the R&D pathway than would be typical, for example, let's say in the semiconductor space. And hence, I think it's extremely strategic that agencies keep this in mind as funding decisions are made, because it has implications on timeline and how you focus investment to go from ideas to wins that you can translate globally.
Thank you. And you talked about that carbon footprint in your comments slightly. The DOE's Office of Fossil Energy,
yes,
has been working, right, to reduce greenhouse gas emissions through their fossil energy research, and you've been involved in that somewhat?
Yeah, so we are actually funded at this point through the National Energy Technology Laboratory.
Wonderful. And certainly I agree that, that across the field we need to develop technologies to reduce our carbon footprint, which is what I'm very proud of in terms of supporting a bill to make advanced gas turbines more efficient. The gas turbine R&D bill that I'm carrying with a fellow Republican would authorize DOE's Office of Fossil Energy to carry out a multi-year, multi-phase R&D program to improve the efficiency of gas turbines used in our power generation systems to identify the technologies that ultimately will lead to gas turbine combined cycle efficiency of 67%. What might seem just like a trivial improvement, but tremendously important in terms of electrons saved. If members of Congress are going to claim to support an all-of-the-above energy philosophy, then we need to support and fund an all-of-the-above research strategy to complement it. That means supporting robust funding for EERE and certainly for ARPA-E. Dr. Venke, we know that ARPA-E plays a critical role in expanding our portfolio of innovation programs and lowering the risk on projects that would not be supported by the private sector. Can you give some examples of how the products, processes, fuels, or technologies that have been developed as a result of ARPA-E's investments are changing our energy system and addressing the challenges we face?
As I mentioned to another question from the congresswoman from Hawaii, the National Academies recently issued a study. Of course, ARPA-E is still in an early stage, it's only 4 years old or something like that. But there are several examples where, which they highlighted. One was actually from Harvard with the slip-on technology. And I know of 2 or 3, Transform, which is done at Santa Barbara, gallium electronics, which has blossomed significantly. And as I mentioned in my previous response, they also have been doing some very good science. So it's both. It's really a missed opportunity if you don't do them together. And so it's really, there are so many good examples. They're the right track. And I will hasten to bet that 10 years from now, in the fullness of time, we're going to have lots of examples because there's both good science being done and patents being created.
Thank you. Thank you very much. I'm out of time, so, Mr. Chair, I yield back.
Thank you, Mr. Tonko. The gentleman from Texas, Mr. Babin, is recognized.
Thank you very much, Mr. Chairman, and I appreciate all you witnesses being here today. Dr. Sant, I would like to ask you a couple of questions, if you don't mind. Can you explain the upcycling process in layman's terms?
Sure.
And how the process differs from traditional approaches to carbon utilization, if you don't mind?
Sure. So in a brief sentence, we can define upcycling as beneficially utilizing a waste. So it's this idea of converting trash into treasure.
Right.
We combust fossil fuels. We emit carbon dioxide from the stack. The work that we're focused on is really trying to take that carbon dioxide and reutilize it. Now, the way we reutilize it is we use this compound called calcium hydroxide, which you produce, for example, by either burning limestone and emitting CO2, and so hence it lets you keep the same mineralized CO2 within a loop. So that's how you reuse it. The other way you can actually produce calcium hydroxide is by using alkaline waste that you get from industries like slags and fly ashes, as an example, and extracting calcium and magnesium ions out of those. So what you're really looking at doing is creating, let's say, a chemical sponge to soak carbon dioxide. And over the course of that reaction, you undergo a transformation to produce limestone. Now, an important thing to point out about this upcycling process is the reason that it turns out to be very attractive, it gives you a strategy for both avoiding and reducing the amount of carbon dioxide you would produce otherwise by producing traditional ordinary Portland cement. That's an important thing because What you can do with this approach is you can create an offtake partnership. So essentially, a power producer can work alongside a cement producer. Since both of them emit CO2, but one produces a material that can potentially soak up CO2, you let these industries actually start to work together. I think these sector-level synergies are extremely important to catalyze, because as you go forward and we look at this idea of trying to create new synergies and new efficiencies in the energy space, we need to get industries that were otherwise not, let's say, correlated with each other, interacting with each other.
All right, what is, if this was a widely deployed process throughout the land, what would be the impact? Would it be dramatic? Would it be a partial impact? Please let me know what you think there.
Sure. That's a very good question, actually. So if we assume global scaling of some of these processes which utilize carbon dioxide, landscape analysis that we have done and others have done shows that you can basically use up to about 10% of global CO2 emissions, right? So it's on the order of about, let's say, 3 or 4 billion tons. Now, while 10% seems like a small number, it's actually a really important number, because what you're really showing is a value system and a pathway to creating value that you could not utilize otherwise. So whether you look at concrete, which is one way that you can utilize CO2, or plastics, which is another way to do it, by creating value, you show that there's opportunity where there was none. And I think that's something which is important, for example, for industry to be able to see, because we are very often used to seeing carbon dioxide as a negative. What we're trying to do is really create this positive perception, which is associated with revenue generation, because that helps you really create longer-term pathways, which are associated with more risk, which do, of course, render more permanent solution, but you want to get points up on the board before you go for the big wins every time.
Okay, and then just to maybe enhance what you just said, in what way can your upcycling technology potentially surpass more traditional CO2 utilization, such as through the use of captured carbon for enhanced oil recovery, for example?
So one of the really important things about the work that we're doing is that we can utilize flue gas without any pre-processing or without any post-processing. So an important aspect as to what really drives up the cost that's associated with carbon capture, as an example, or utilization, is lots of these processes require enriched or purified CO2. The way our process is designed is we can basically take flue gas that comes out of a stack in a power plant or on a cement plant or a petrochemical facility and use it directly as a reagent in our chemical process. I think this is an extremely important point, because the cost of capture is really a limiting step at this point. And if you can start to utilize flue gas without a capture cost, now you really start to see some economic viability that can start to emerge with these processes.
Okay, thank you very much, and I yield back, Mr. Chairman.
Thank you, Mr. Babin. And the gentleman from Virginia, Mr. Byers, recognized.
Thank you, Mr. Chairman, very much. Dr. DeWitt, I was fascinated by all your conversation, your work on the small nuclear reactors. I was sitting next to Congresswoman Jackie Rosen from Nevada, and she was sort of, I don't want to mischaracterize, but instantaneously anxious about the fuel. So I pointed her out the first page of your testimony about how you're reusing fuels from so many other places, including the plutonium. At the end of the day, is storage still a problem or an issue that has to be solved with respect to the small nuclear reactors?
In terms of waste storage?
Yeah, exactly.
It's a different problem, but it's a very much smaller problem, in the sense that the output effectively is going to be something that's radioactive for nominally 300 years at most, and a very small volume of what you would produce otherwise. So really what we're doing today is we're taking fuel, we're only extracting about 1% of the total energy content in that fuel, and then we're trying to dispose of it. That's what we're doing today. What we're trying to do, and what other fast reactors can do, is take that and extract basically the rest of that 99% energy content out. Now, there's still some radioactive material at the end of the day, but you can safely store that. It only needs to last for a couple hundred years before it decays away to nothing. At that point, you can have it vitrified. You can make glasses out of it that you could drink out of, in fact. So it would be perfectly safe. It's a very manageable problem at that point.
The sense I'm getting from your testimony is that the development of your fast reactor technology at scale could solve a lot of the disposal problems of the bigger reactors that we have already.
Absolutely. It changes it from a problem to really an opportunity, because now you have a bunch of fuel that we could power the United States on for hundreds of years, like all of the United States power needs. So it's a phenomenal opportunity.
You talked a little bit, I know, before about the Nuclear Regulatory Commission, and they've been adapting to small rather than big. How about the insurance companies, the liability and Are they still treating you like 3 Mile Island, or?
That's an excellent question, and I think it's a question that needs to become more prevalent and mature going forward. There's a lot of differences between small reactors and advanced reactors in terms of what the potential risks are, the potential consequences, and therefore what the liabilities should be and what the insurance capabilities need to be. And generally, it's a much smaller footprint. It's a much smaller need. So the current framework, in some ways and in some cases, is kind of it's inefficient. It's not set to actual technology capabilities today, and that needs to modernize. And I think that conversation in general needs to pick up. Frankly, now is the time to do that.
Great, thank you very much. Mr. Kumaraswamy, had many conversations with folks in your business about the exciting role that batteries can play, especially when you think about power plants as a step-by-step. Do you see this as also promoting clean energy, reducing emissions, having a role in a 21st century electric grid?
Absolutely. I think the way we see it is that it gives us the capability to decouple the demand and the supply piece, which gives us transformational capabilities, right? And so, again, like I said, it has significant potential for you to think about increasing the efficiency that we operate the existing system with, both in the generation and the transmission and distribution side. It's a question that we get asked all the time about whether storage is generation or transmission or distribution, and it's all of the above, really, right? Because it is able to play into all of those areas that we have traditionally assumed to be pretty bifurcated. And like I said previously, when we are faced with a future where the baseload generation plants are facing retirement decisions and we are continuing to add more renewable sources into the grid, there's a need that you have to add more peaking capacity into the grid. And the most cost-effective way of providing that peaking capacity is through deployment of large-scale energy storage. So we're pretty.
So you're working with Elon Musk on all these electric cars and steering wheels, cars without steering wheels, things like that.
We might buy some other products.
All right. Dr. Venke, one of the criticisms that's often come from my friends on the other side about Department of Energy was picking winners and losers and interfering with the free market by crowding out private investment. But you worked at Bell Labs, you work at Sandia National Laboratory. How do you perceive this? And what's been your experience about the federal government having a role in these things?
Well, first of all, there are many forms in which you can actually interact with industry. But the early stages, you take ARPA-E, they are having wide solicitations. They ask for a lot of different proposals. They get reviews of them. And obviously, some people get selected, some don't. This is true for even academia. So it's quite a robust process, but you're risky, so it's not going to be perfect. In a sense, you must pick winners and losers, so to speak, and hopefully the ARPA-E program managers are wise enough that, and long term, of course, it eventually goes into. So I just don't see that argument at all, as long as the process is fair, and this is how it is done. There's always a judgment question. This is true. I complained when my grant is not approved. Was they unfair to me? As long as the process was robust. So the other feature which I think is important is there are many different kinds. There can be joint agreements with industry where they actually putting skin in the game and say, we want your help. That's cooperative research and development agreements. So we should allow for different forms. It goes on different industries. But the early stage part, I don't see that as an issue. Even in the very long range start, as long as we have an open process, and we have this thing properly documented, that would be correct. Great. And the loan guarantee program has been under debate. That's the one where you can actually have a serious argument. It, of course, has to be done with much greater care because the amount of investment is huge.
Great.
The ARPA ones are small.
Thank you, Doctor, very much. Thanks, Mr. Chairman.
Thank you, Mr. Beyer. And the gentleman from Kansas, Mr. Marshall, is recognized for his questions.
Thank you, Mr. Chairman. My first question is for Dr. Sant. Dr. Sant, Chairman Smith and I had the opportunity to recently see what we believe is the country's largest 3D printer at Wichita State University. And one of the technologies they showed us was additive manufacturing to the 3D printing, and they described it as a potential game changer for manufacturing. Can you talk a little bit about how you think that they could use this additive technology to manufacturing? Would it help you scale up your technology?
Yes, indeed. So actually, we are working on additive manufacturing, specifically it's related to construction systems. In fact, there's great opportunities. An important part of what we're working on, and I think we've stumbled into this, but it's turned out to be a major opportunity. the material that we're working with is much easier and much better suited for additive manufacturing than traditional concrete. And this turns out to be quite an advantage for a variety of reasons. So traditional concrete has amongst the poorest what you call strength-to-weight ratios of synthetic materials. Using additively manufactured components lets you use materials a lot more effectively. So if you imagine that you can produce structural elements, beams, columns, and slabs, and take them out to a construction site and start to assemble them, kind of like a large Lego set, that has major impacts on the construction sector because it really starts to improve construction productivity. If you can imagine, very often we hear of construction projects being delayed. If you can imagine you're taking pre-built sections out on site and starting to assemble those, that's a much more efficient process to be able to construct with much more efficient systems. So additive manufacturing, clearly in our minds, is the path forward as far as construction goes.
Well, thanks. And I'm going to always remember as they showed us the structure of wings for airplanes. They, of course, manufacture lots of airplane stuff in Wichita. And they basically told the computer to make it stronger, and it ended up looking like a bird's wing and just the microstructure of it. I'll go to Mr. Kumaraswamy next. Battery storage is a huge issue, obviously. A third of the energy in Kansas is now generated via wind energy, and the storage of that wind energy is always the challenge. And we hope to be, we are already an energy exporter from Kansas. So just talk a little bit about your technology. As I understand and read your process, it's your batteries are side by side by side. What's the future look like for battery storage, or what's your vision, and where do you think we're going with this?
Sure, that's a great question. We, the product that we have, which is called EventID, is an energy storage platform. We are not a battery manufacturing company, so we actually buy batteries and inverters from many different certified suppliers. It's a platform that we have developed that actually has some unique advantages in terms of serving the grid. It's pretty modular in terms of the architecture that we have come up with. And again, we are in a leadership position in deploying grid-scale energy storage solutions, both nationally in the US and globally. For the specific issue that you mentioned, there's significant applications of energy storage. So if you have intermittent variable generation, one of the issues that you have is making sure that the time in which the generation actually is produced aligns with the peak times in which the demand occurs on the grid condition, right? And so oftentimes what we see with both wind and solar generation is that there is a misalignment of when the generation production happens and when the demand for electricity happens in the late evening hours when people actually come back home. And that's one of the applications of energy storage, is the ability to actually move all of the generation that's happening in the early afternoon periods towards the early evening periods when the demand hits its peak. And we are currently deploying some of these longer duration storage projects also. We have a project that's currently under construction in California. It's a 100 megawatt, 400 megawatt hour energy storage project. So it's a 100 megawatt, 4 hours of duration project. So think about moving your generation from the 4 p.m. hour to the 8 p.m. hour. That can be completely done. And we think that it's the most cost-effective way in which you can accomplish that objective.
I mean, are these still just commercial batteries side by side, or what's that look like?
It's lithium-ion batteries. The EventID platform that I mentioned is largely agnostic to technology. We basically look at whatever technology makes the most amount of sense for our end-use customers, which are utilities in most cases. But till date, what we have found is that lithium-ion has the best amount of efficiency and cost-effectiveness right now. And as far as we can see, that still applies, at least in the next 2 to 3 year time frame, with the synergies that lithium-ion technology has with the transportation sector on the electric vehicle side. It still continues to be the technology that we're anticipating will provide the characteristics that can be helpful for the grid.
Okay, thank you. I wanted to talk nuclear engineering, but I'm out of time. Thank you, and I yield back.
Thank you, Mr. Marshall. And the gentleman from Florida, Mr. Christ, thank you for your patience.
Not at all. Thank you, Mr. Chairman. And thank to all the panelists for being here today to share your unique perspectives on energy technology, research, and development. I'm from Florida, the Sunshine State, where our energy is our economy and our environment. Protecting our natural resources is of the utmost importance to myself and the constituents I represent. That's why I'm extremely interested in increasing the use of clean energy to meet our environmental needs, particularly in the area of solar. Mr. Kumaraswamy, from my understanding, better energy storage technology could help the U.S. to greatly expand our portfolio of zero-emission energy sources. Can you discuss how energy storage can be combined with renewables like solar and wind to help reach our clean energy and environmental goals?
Absolutely. Just also as a note that the U.S. actually has a leadership position in terms of deployment of grid-scale energy storage. I think as of Bloomberg data that's a couple of months old right now, we have more than 30 to 40% of the global energy storage installations across the whole world. So it's something that we should be proud of. And energy storage, again, it's one of those things where there's significant potential for using that along with renewable energy technologies like solar and wind. AES actually is currently also developing a project in Kauai, in the island of Hawaii, which is a combined solar plus storage project, right? And so it's a combination of solar technology and battery-based energy storage technology to make sure that you almost create a firm block of power that can be delivered to the grid. Like I was mentioning previously, one of the things that you have to worry about if you have intermittent variable generation is the misalignment of when the generation occurs in the system and when the demand actually peaks. And storage is the glue that can help you bridge that gap that you have in the system. And the other issue is also that in several cases, what we see is that when you keep adding more variable generation into the system, there's a tendency for us to think about adding more peaking gas plants to balance all of that renewable generation. In our view, it's not the most prudent choice to add capacity into the grid that runs for like a fraction of the year, right? If you think about peaking gas plants that we have across the country, the average capacity factor of that is something like 5 to 6% of the year. In an economy where we're moving towards shared services in pretty much every commodity that we think about. If you think about Airbnb on the hotel side or Uber for the transportation side, we are thinking about shared services, right? And so in that economy, we think that if you make multi-billion-dollar investments into peaking gas plants that run for a fraction of the year, that's just not in the best interest of ratepayers. And I think storage would be a lot more cost-effective in performing that function.
Yes. Is the same type of energy storage equally suited to grids powered by different energy sources, wind versus solar versus natural gas versus coal-fired power plants, or would it make more sense to use several different types of energy storage?
The storage itself is agnostic, again, to the type of generation that you have. It just gives you the capability to store energy and release it at a later point in time, right? And so it's agnostic to whether it's coal or natural gas or renewable source that you actually use to charge. But again, in many markets that we have gone into, we have seen significant benefits, including environmental benefits, that additional storage brings to the grid. Part of the reason is also that it lets you optimize the existing portfolio of generation plants to operate more efficiently, right? Because as the demand keeps changing, your power plants keep moving up and down their heat rate block. Basically, they're consuming more fuel or less fuel to balance the needs of the grid, right? If you add storage into the system, the storage actually is able to take up the job of moving up and down to balance the demand conditions, letting the existing power plants operate much more efficiently, which means that they're running at better heat rate blocks, at better efficiency blocks, which means that their emissions go down. So that's a significant benefit that we have seen in some of these markets.
Well, thank you. It's clear to me that we need greater energy storage in America. What can the federal government, Congress in particular, do to help encourage additional research and development in this field, in your view?
Like I mentioned in my testimony, I think on the lithium-ion side of the house, I think the technology is stable. There's a lot of private capital that's chasing more innovation, like improving cell density and reduction of costs and all of that. So I think private capital will continue to push that forward. There is a significant role for us to make investments in early stage R&D on other promising battery chemistries that have greater potential in the near future, like extending the duration in which you can actually store energy, right? So I think that's an area that the government should continue to focus on. And I think the second and most important area is also that we want greater recognition of the benefits that storage brings to the grid, particularly for applications like peaking capacity, right? When we go and talk to regulators across the country, it's one of those common questions that we bring up all the time, which is, how does it compare with a peaking gas plant? And it's an apples to oranges type of comparison because a peaking gas plant has to be turned on to provide a service, and then it shuts off. And when it shuts off, it can't provide a service. In contrast, energy storage is a 24/7 resource. It's connected to the grid all the time. So when you need that peaking capacity, it's able to discharge and provide you that capacity. And for the remainder of the day or for the remainder of the time, it's actually able to provide for other ancillary services that are needed for the grid. And so the other area of focus should be continued investments in the national labs to make sure that there's awareness of all of the benefits that storage brings to the grid.
Thank you. Thank you very much, Mr. Chairman. I yield back.
Okay, thank you, Mr. Christ. And again, thank you all, our experts, for being here today. The testimony to me was very informative and very valuable to us. The record will stay open for a couple of weeks in case members have additional written questions they want to submit. And that concludes our business, and we stand adjourned.